Hey everybody, in this video we're going to talk about finding the equations of tangent and normal lines to a curve. Alright, so we've got this quadratic here, x squared plus 1, all kind of sketched out for us, and what we're going to do is we're going to find the equations of the tangent line at x equals 1 and the normal line at x equals 1. Now the equations of the tangent and normal lines can be put into point slope form, which is y equals mx plus b, or what we call point slope form, which is y minus y1 equals m times x minus x1. You can use either one of these. They both work just fine, and it's really based on preference or what's being asked of a particular problem. Now, one thing to know about the relationship between normal and tangent lines is that the slope of the tangent line times the slope of the normal line equals -1. That's because these two lines are perpendicular to each other. So if you multiply those slopes together, you'll get the product of -1. Now, we said we're going to start where x equals 1, so let's find 1 on our graph here, and we'll plug that into our equation. 1 squared plus 1, so y is 2, so we are talking about the point 1, 2, which you probably could have seen from the graph just if you were able to look at that closely, but I like to do it this way just to make sure that I'm not missing anything, so I always plug it in just to make sure. Alright, so the tangent line is the line that touches the curve at any given, or at any point along the curve. It only just touches it, it doesn't cross it. And the slope of this is the derivative of the original function. So if we were able to, or if we needed to, we could actually put that function, that derivative function, into the equation if we wanted. But since we have the point, we can find the actual slope of the tangent line at that point. So what we'll do is we'll take the derivative of our function. Remember, the exponent comes down, we subtract 1 from the exponent, and the 1 goes away, so we're left with the slope of 2x. If you don't remember how to do derivatives, go back to one of the previous videos that we have, and it kind of goes through that. Okay, so we've got our slope at 2. The equation for the slope is 2x, and we want to know what it is at the point x equals 1. So we're going to drop that into there, and so we see our slope is 2. So our tangent line slope is 2, or 2 over 1 if you want, but we'll just leave it at 2 for ease of calculations. So let's find the equations of the tangent lines. So you could either use the mx plus b format, or you could use the point slope format. Either one is fine. I'm going to start with the point slope because we have our point 1, 2, so I'm going to drop that into our y1 and our x1, and we get y minus 2 equals 2 times x minus 1. Okay, so you could leave it right here. This is a valid answer. I always prefer going to the slope-intercept form, so I'm going to work it through, but remember, you could leave it right here. So first thing I'm going to do is I'm going to distribute the 2 across the parentheses and get 2x minus 1 on the right side of the equation. Bring that -2 over, and we're left with our equation of y equals 2x. Now, the fact that this equation is the same as the equation for the slope is purely coincidental. This is not something that you are going to see all the time. This is just so happens that this is what it works out for this particular problem. Alright, so let's check our work on the other side. Well, actually, we can also confirm with the equation first that with the graph that we are going through the origin with our sketched blue line too. Again, I like to go with actually determining the equation first instead of what I sketch out, because my sketches are always off a little bit. So it gives me a good idea, but it doesn't necessarily get me to the actual answer. Okay, so let's work through the slope-intercept form. So we know that 2 equals 2 times 1 plus b. Simplify, take that 2 over, we get our y-intercept is 0, so we get y equals 2x, and that confirms what we did before. Perfect. Now let's look at our normal line. So the normal line is perpendicular to the tangent line. Alright, so what is the slope of the normal line? Well, you may be able to figure this out pretty straight away, but remember, we're talking about the point 1, 2, and we know that the slope of this at that point for the tangent line is 2. So we can just put this into this little yellow box up here and say, well, 2 times whatever the slope of the normal line is going to be -1. Well, how do we find out what the slope of the normal line is? Well, we simply solve for the normal line, divide both sides by 2, and we get the slope is equal to -1/2. Fairly straightforward. A lot of people get tripped up by this, but it's a fairly straightforward idea as long as you remember that the product of these two things is -1. So now we can confirm this by kind of looking at the graph. We can see that the slope roughly looks like it's going to -1/2 as well, down one over 2. But let's find our actual equation for it. So the normal line, y equals -1/2 x plus b. Solve for our intercept and plug in our point. Distribute that -1/2, bring the -1/2 to the other side of the equation. So our b equals 3 over 2. And if you look at the graph, it does look like it goes roughly through 1.5 or 3 over 2. So we're looking good there. Take it back and put it into the equation, the point slope form, or sorry, the slope intercept form, and we have our equation y equals -1/2 x plus 3 over 2. Okay, let's confirm with our other method. So we've got our point and we've got our slope, so we drop it into the equation. Again, you can leave it right here if you want. Depends on what's being asked, but you can see that's in point slope form. Or we can take it through and confirm that it matches our slope intercept form. So we're going to distribute that -1/2. We're going to bring that 2 over, and we again get -1/2 x plus 3 over 2, so we confirm that. So now, going through all of this, it's a lot of information shown here. You might be asked for just the normal, you might be asked for just the tangent line, but let's look at the things that you need in order to solve these types of problems. So the first thing you need is an original function. You need the function that you're working on. You may have a graph, you may not, but you need to have that original function. Second thing you're going to need is an x value on the original function. Sometimes this will be shown as a point, sometimes it will not. So, but you need an x value that's going to be on that function somewhere, somehow. Next thing you're going to need is to find the derivative so you can find the slope of the tangent line. Now, this could also be given in terms of a parallel line, where you know what that is, but you need basically the slope of the tangent line. So if they say what's the slope of a line that is parallel to the tangent, and the slope, or the slope of a line parallel to the tangent is blah, you could also use that in there as well. But basically you need the derivative so you can find the slope, or you need to have the slope for the tangent line. Finally, what you need is to find either the tangent or the normal line. You need to know what you're looking for. So after you know that, then you can solve accordingly. Sometimes you don't need to go through everything that we've done here in this video, but you'll need to go through bits and bobs of it, bits and parts of it. So keep track of what you are actually looking for. Alright, so that's it for this video. I hope that helped kind of determine how to find these things and what you need to find equations of tangent and normal lines, and I'll talk to you in the next video.